In this section, we will look at combination. So, as we've seen with permutation, the order matters. A set of A, B, C is distinct from a set of C, B, A. However, with combination, the set order or organizing or arranging items does not matter. A problem where combinations are a useful tool will only care that certain elements are in a set, not about the order in which they appear. Let us continue our swimming theme, but change the competition. Let us consider a swimming race in which the first 4 swimmers to finish all get the same award. If the order does not matter, then we will run into the problem of redundancy. For example, let us say that we have swimmer 1, 2, 3, and 4 all finish the race first. In our example race, where each of these swimmers will get the same award, giving out awards to swimmers in this order, 1, 2, 3, 4, is the same as giving out medals to swimmers in this order, 4, 2, 1, 3. So we will need to deal with that as we count the possible combinations. If we want to figure out how many combinations we have, we just create all the possible permutation and then divide that by redundancy. Remember that to calculate the permutation means dividing all of the possibilities of arranging our sets by the number of items in our set minus the number of items we want to order. In this situation, we have 8 swimmers and 4 awards. So we have 8 factorial divided by 4 factorial, and we get 1,680 permutations. And we divide this by 4 factorial for redundancy for each permutation, and we get 1,680 divided by 4 factorial equals to 70 combinations. Presented here is the combination formula. Notice how the base of the formula is identical to the one we use for permutation with addition of accounting for redundancy. If we plug in the numbers, we take the total of swimmers, which is 8, and divide it by the number of ways we can hand out awards, which is 4. Now let us work through simplifying. 8 factorial divided by 4 factorial multiplied by 4 factorial. We will first expand the numerator and the denominator as shown here. We will then cancel out the values, leaving us with 8 on both the numerator and the denominator, then cancel 3 from the 6 in the numerator to get 2, leaving us with a total of 7 times 6 times 5. Finally, we use standard multiplication and multiply 7 times 2, 14 times 5, we get 70, and that is our combination. So in this video, we concluded combination after the permutation video, and we looked at the differences and similarities between them. Remember that permutations help us to calculate the number of possibilities of arranging a set of items when the order of those items is important. Combination allows us to calculate the number of possibilities of arranging a set of items when the order of those items is not important. Please do not memorize these formulas. Remember to go back and look how we got here, and this will help you understand permutation and combination better.